Hello everyone and welcome. In this video I'm going to talk about pointers in C++. Now in order to explain pointers I'm going to talk a lot about references as well, so if you don't know what a reference is, you should definitely go learn. I have a video about that in my channel, so you can go watch that video if you want. So let's get into it. Now, a reference and a pointer are basically the same thing, and they're often referred to as such, but they do have some slight differences that I'm going to explain. So now I'm just going to go over what is happening in your computer's memory when you create a pointer versus when you create a reference, and then I'm actually going to explain pointers with code in C++. Okay? So imagine that this is your your computer's memory. Okay? Now, your computer's memory is divided into locations, okay? It's divided into little slots, okay? It's basically like a line, a strip of digits, of bits that are divided into locations, okay? Now, when you create a variable, for example, a equals 2, basically what is happening is you're allocating memory to store that variable. So you're using a piece of memory to store that variable, and that piece of memory is going to be a distinct location in your computer's memory, okay? So for example, here, okay? So this is a slot in your computer's memory. When you create a variable, the value of that variable is going to be stored in one of those slots, and basically what the variable is going to be is it's going to be a little arrow that is pointing at that memory location. Okay, so this is going to be A, okay? Now, when you access the variable A, basically what you're doing is you're going to this arrow right here, you're seeing what it is pointing at, and you're getting the value that's stored in the memory location that the arrow is pointing at, okay? Of course, these are just illustrations. This doesn't actually happen like this, but just so you understand what is happening in your computer, okay? Now, when you create a reference, for example, %b equals A, basically what you're doing is you're creating another arrow that's pointing at the same memory location as the variable that's being referenced, but it has a different name. So this is going to be B. Okay, so you have two arrows pointing at the same memory location. One of them is the variable A, the other one is the reference to A, which is called B. Okay, so a reference isn't a new variable. You're not allocating new memory to store the variable B, because it is not really a variable, it's just a reference, it's an alias, it's basically another name for the variable A. And so when you access B, you're accessing the same memory location as A. So accessing the reference to A, B, or referencing the variable itself, A, is exactly the same thing because they're both pointing at the same memory location, okay? So this is how a reference works. Now, a pointer is a little bit different because a pointer isn't really an arrow that's pointing at a memory location. A pointer is a variable that is storing the memory location of a variable, okay? So if you create a pointer called C, to create a pointer, you're going to put an asterisk before the name of the variable. I'm going to show you how to do this in C++ later on. So a pointer called C is going to be equal to %A. Now, in this case, the %, doesn't indicate that this is a reference. It just indicates that this is the memory location of A, okay? Now, again, a pointer is a variable that's storing the memory location of another variable, okay? So a pointer, being a variable, is going to have its own memory location, and it's going to be accessible through that memory location, okay? So for example, this is going to be the location of C, and so this is C, okay? When we access C, we're going to access this memory location right here. So we're going to access the memory location of A, okay? So this is how a pointer works in C++. Now, I hope the difference between references and pointers was clear. Now let's get into the code, how to create references, how to create pointers, and all of that. So first of all, I'm going to create the variable A, which is going to be equal to 2. And now I'm going to create a pointer, okay? Now, a pointer is always an integer independently on the data type of the variable that you're storing in the pointer. So int, and now, int, and now an asterisk to indicate that this is a pointer, the name of the pointer, which is going to be C, and this is going to equal %A. Now again, this % is not indicating that this is a reference, is just indicating that this is the memory location of A and not A itself, okay? So this is the variable, this is a pointer. Now let me output the pointer to show you what this looks like. So if I run this, this is going to output a random set of numbers and letters, which is actually the memory location of A. Okay, so that's what the pointer is storing. Now you can do something which is called dereferencing the pointer. And when you dereference a pointer, you're not going to be accessing the memory location that's stored inside of the pointer. So you're not going to be accessing the pointer itself. You're going to be accessing the value that's stored in the memory location that the pointer is holding. Okay, so now to dereference a pointer, you just have to put an asterisk before the name of the pointer when you output it. And now when I run this, instead of this outputting the memory location of A, this is going to output the value that's stored in the memory location of A, so 2, okay? Now to prove to you that a pointer has its own memory location, I'm going to see out the pointer C, then an end line, and then I'm going to see out %C. Okay, so this %C is going to be the memory location of C, and C is a pointer that's storing the memory location of A. So this is going to print the memory location of A, an end line, and then the memory location of C. Okay, so if I run this, as you can see, this is going to give me two different sets of numbers and letters, which are the memory locations of A and C respectively. Okay, so now that you know what a pointer is and how to create one, I'm going to teach you some rules that you need to keep in mind when you're using pointers, okay? So first of all, I know I told you that pointers are always integers, and that is true to a certain extent, but in C++ you can do something which is create a void pointer. Basically means that that pointer isn't going to have any type, okay? So to do that, you just write void and then asterisk and the name of the pointer and then the %A, which is like the memory location of A, okay? So this pointer right here, Z, is a void pointer. What that means is basically it doesn't really have a type, okay? Now, how is this possible? Well, in C++, every variable has a data type, right? Now, why do you need to specify the data type of the variable? Well, that's because different data types occupy different amounts of memory. For example, a bool or a char occupy 1 byte of memory, an integer occupies 4 bytes of memory, and for example, a string occupies 24 bytes of memory. So if you want to keep a variable uninitialized, meaning you want to create a variable but you don't want to give it a value, then the computer isn't going to know how much memory it needs to allocate in order to save that variable, right? So you need to specify the data type of the variable, because then even if you don't initialize it, the computer is going to know exactly how much memory needs to be saved in order to store that variable, right? Now, pointers in C++, they're always going to occupy the same amount of memory because they're always going to be a memory location, right? And this is the reason why you can create void pointers. You don't really need to give a type to your pointer because the computer already knows how much memory a pointer takes up because they take up always the same amount of memory. So yeah, you can have typeless pointers, and something that you can do as well is you can leave a pointer uninitialized. You can just create a pointer and not assign it any value, right? Because a pointer, like I said, is a normal variable. Instead of storing a certain value, it just stores a memory location, but it can be uninitialized. It can not have any value but be defined, okay? Now, another thing you can do is you can actually assign the value null to your pointer. Now, null is a keyword that basically means 0, okay? This just basically means that this pointer is equal to 0. Now, 0 is not really a valid memory address, so this is not really a valid value for a pointer, but an invalid pointer is perfectly fine in C++, okay? That's an okay state for a pointer to be in C++, and so you can do this if you want. Now, another thing that you can do is you can actually modify pointers. Now, this is something that you can't do with references, right? Because once you create a reference, you cannot change what that reference is referencing. With pointers, you can change what the pointer is pointing at, okay? So let me create another variable, which is going to be called b. It's going to equal 3, for example. And then I'm going to say that C is a pointer that's pointing to the memory location of A. And then I'm going to change C, I'm going to change C like this to be the memory location of B. So now if I see out the memory location of A and then end line and then C, if I run this code, this is going to give me first the memory location of A, and then it's going to give me the memory location of C, right? Because in the beginning, C was storing the memory location of A, but then I changed it to be the memory location of B, which is perfectly valid, which you can't do with references. Okay, you cannot do this with references. And then I see added the memory location of A and the pointer C, which is storing the memory location of B. And that's why I got two different memory locations, okay? And you can also have pointers that are pointing at pointers, so pointers of pointers. That is perfectly fine to do. You can have a pointer that's pointing at the memory location of another pointer. And I think that's all I had to show you today. Okay, you can have void pointers, which are typeless pointers. Your pointer can be equal to null, although that is invalid. That is perfectly okay to do. Your pointer can be uninitialized, it can be pointing at another pointer, and it can be modified after it being created and initialized, okay? So thank you so much for watching. If you found this video helpful, if you understood it well, if you think I explained it with clarity, please like and subscribe to support the channel. But for now, thank you so much for watching. If you have any questions, don't hesitate to ask, and I'll see you in the next video.